Topic today is what is reflection of sound or echo. What is reflection of sound or echo? We also call it echo. So when its answer is when sound hit some surface of a medium, then it bounces back into the same medium. It is called reflection or echo of sound. So if we speak or we produce some sound, then the sound waves hit some surface and these are bounced back. This bouncing back is known as reflection of sound or echo. Now we will discuss what is the reason behind it. Reason for echo. Reason for echo is this, that whenever a sound is heard, whenever we hear a sound, its impression persists in our brain for it persists in brain for 0.1 second. And after 0.1 second, it vanishes from our thoughts, from our brain. It's like if you see a lighted bulb for a while and then you close your eyes and try to see the same image, you will see the lighted bulb in the darkness. And that also is approximately for 1/10 of a second. Now, what happens for echo to be heard the same voice again? If we speak somewhere in the hilly area, we hear the same sound again and again. That is in fact known as echo. And what happens if we are standing in front of some hurdle? It must be at least 17 meters away from us. Why? Because if we consider velocity of sound as 340 meter per second at normal temperature and pressure, then if time is 0.1 second, then we calculate the distance traveled. S is equal to V into T. We get 340 multiplied by 0.1 is equal to 34 meter. If you calculate it, it comes 34 meter. So it means the sound, if we clap in front of some hurdle, okay, then the sound moves away from us towards the hurdle, and then it comes back, and if the time taken is 0.1 second, then it has covered this total of 34 centimeter distance. Both the distance are same, therefore we divide it by 2, so we get 17 meter taken to go and 17 meter taken to come back towards us, and we hear the same sound again. So least distance to hear a clear echo, the distance of the hurdle must be equal to 17 meter. Now we come towards another point, and that is, how will we prove that sound reflects? For it, we will perform an experiment. Suppose that we have a hurdle, a wall, say called A, B, C, D. It's a wall in front of us. Here we place, and it is a hurdle placed on a table. These are the legs, and this is the table, and here it is hurdle perpendicularly placed on this table. Here we place, first of all we draw a normal, say ON, a line which is perpendicular to this hurdle. We place a PVC pipe in front of this hurdle, making some angle. See, angle of incidence I. And we place another cardboard. Insert in the beginning, it has not an angle equal to angle I. We will adjust its position. We place a clock which has a ticking sound, ticking clock, because we need a tick tick sound over here. We place it in front of the opening of the first PVC pipe, and from this side we will try to hear the sound. What we will do is that we will try to adjust this here, say adjust this second PVC pipe When the ticking starts moving from here, enters in this pipe, hits at point O, and it reflects back, then what we do is we adjust the position of this green PVC pipe. Here we start moving it away and we stop it where we hear a loud sound. If we move it further away, we will hear faint sound. So it will be adjusted at a point where the sound is loud. So we adjusted it, and we see that we hear a loud sound over here at this position. If we calculate the angle which is made with this normal, we will come to know point number 1, that angle I is always equal to angle R. So first conclusion is, when sound waves travel from the source of sound, hit the hurdle, then these are reflected back, making an angle of I equal to angle R. What is angle I? Angle I is the angle between incident waves and normal. And what is angle R? Angle R is the angle made or subtended between reflected waves and normal. And both these are equal in measure. Now we will testify a second thing. What we do is we will try to lift this green PVC pipe up to some height, and we will try to hear the sound. Again, the sound is faint. So it proves that the sound is loud if this PVC pipe, green PVC pipe, remains in the same plane, in the plane of this table. If we try to move this PVC pipe out of this plane, then we hear faint sound. So we came to know another important point, that the the incident sound, the normal at the point of incidence O, and the reflected sound, all these four lie in the same plane. If we move it out of the plane, the sound starts becoming fainter. So we got another important point, and that is incident waves, incident sound waves, normal at point of incidence, and reflected sound waves all lie in same plane. So these two concluded points are called laws of reflection in case of sound waves, also in case of water waves, and also in case of light rays. In the three chapters we discuss these two laws, how we will say angle of incidence of the sound waves is always equal to angle of the reflection of the reflected sound waves. And second thing, incident ray or incident waves. In case of light, we say incident rays. In case of water, we say incident water waves. In case of sound, we say incident sound waves. Normal ON at the point of incidence, and the reflected sound waves. All these 1, 2, 3, 4. All these lie in the same plane. If we try to come out of this plane, then the sound becomes fainter, which proves that the second law holds over here in this experiment.